Assalamualaikum and good morning. Today, my friend and I will be presenting this video about machine learning. My name is Fahmi Iskandar and I'll be the one who started it. Yeah, this is supervised machine learning video from TikTok account called FakeWorld541. Here it shows an AI-powered CCTV that tracks and labels people and vehicles using this green and red block. Every block here represents every people and vehicles the CCTV sees. Okay, so we can divide this into three categories, which is input data, what the system learned, and why it's supervised. So input data, thousands of hours of camera footage, LiDAR point clouds, and radar data where human annotators have manually drawn boxes around objects and labeled them. What the system learn? It learns to recognize pixel patterns, shapes, and boundaries that constitute these specific objects. Why it's supervised? The algorithm trains on a data set where the ground truth answers, aka labels, are already provided. If the system misidentifies a mailbox as a pedestrian during training, the error is calculated against the true label, forcing the model to adjust its weight until its prediction matches the human provided labels. So that's all for supervised machine learning. So moving on to this next one.
My name is Izmal and I will talk about unsupervised learning. This clip shows how AI maps out where people crowds in a store. See a tiny video in the bottom right. That is raw security footage. The AI scans its spot every person and tracks these footsteps. Now look at the main screen. The AI takes all those thousands of footsteps and groups them using calculation. It doesn't actually know whether it's a shelf or distance, but it automatically colors the heavy crowding zones bright red and the empty areas. It's just a super easy way for store to fix the layout without watching hours of boring footage. Next. Next, the first one is input data. Thousands of frames of raw unlabeled time-lapse video footage captured by overhead retail security cameras containing only the moving visual pixel coordinates of shoppers traversing the store floor. And next, what the system learns? It learns to identify hidden spatial structures, dense geometric groupings, and frequency distribution of coordinates points over time without being given any store layout blueprints or checkout zone definition. And lastly, why it's unsupervised. The algorithm analyzes a completely raw dataset where no ground truth answer or human annotated category labels are provided. It eventually spatial density purely through mathematical distances like point accumulation tracking, originally clustering high traffic zones into vivid color gradient based solely on natural underlying patterns of shopper behavior. And that's all for me.
Hello, my name is Chong. Today I am presenting a real-life example of reinforcement learning using an autonomous robot called a GP shooter or AMR, which is a very smart way of shooting. Next. They have three types of input data. First, LiDAR and depth camera. Second, downward facing camera. And third is internal system status. So what the system is trying to learn? The robot is trying to learn optimal navigation policy. This means the faster, most collision-free path from the package up to the target shooting bin. And finally, why does it belong to reinforcement learning? It belongs to reinforcement learning because it operates entirely on agent environment, iteration, loop driven by rewards and penalty rather than fixed data set or human label extraction. Over thousands of trials, the robot optimized the choice to maximize its rewards efficiently, teaching itself how to master the warehouse flow. Next.
Okay, so that's all from us. Thank you so much for watching this video. Reminder, for illustration only, selected with care to ensure a safe, respectful space with zero intent to cause emotional distress or harm. So that's all from us. Thank you.
Thank you. Goodbye.